Basic network topology and SONET. Basic network and topology. The network topology defines the way in which computers, printers, and other devices are connected, and network topology describes the layout of the wire and devices as well as the path used by the data transmission. This shows the various types of topology. Bus topology, in which the rings nodes are connected in form of bus one by one. This is a ring topology. In ring topology, the nodes nodes are connected in form of ring. The output of one node is connected to the work is the input of other nodes, and input of other node work is the output for previous node. This is one is the star topology. The nodes are connected into the star form. They are centrally connected to each other. Extended star topologies, the star are further extended. Mesh topologies, the nodes are closely connected to each other. Means each node has three output. Each node, each node has. This shows the 5 nodes, and each node has each node has 4 outputs which are connected to each other. Bus topologies, now we have described it details. Commonly referred to as a linear bus, all the devices on a bus topology are connected by one single cable. A star and tree topology. The star topology is the most commonly used architecture in Ethernet LAN. When installed, the star topology resembles spokes in a bicycle wheel. Larger networks use the extended star topology, also called the tree topology, when used with network devices that filter frames over packets like bridges, switches, and routers. This topology significantly reduces the traffic on the wires by sending packets onto the wire of the destination host. Ring topology. A frame travels around a ring, stopping at each node. If a node wants to transmit data, it adds the data as well as the destination address to the frame. The frame then continues around the ring until it finds the destination node, which takes the data out of the frame. Single-ring. All the devices on the network share a single cable. Dual-ring. The dual-ring topology allows data to be sent in. The mesh topology. The mesh topology connects all devices nodes to each other for redundancy and fault tolerance. It is used in WLAN wireless area networks to interconnect LAN and for mission critical networks like those used by the banks and financial institutes. Implementing the mesh topology is expensive and other difficult. SONET multiplexer and demultiplexer. The synchronous transfer signal level 1 STS1 is the basic building block of the SONET hierarchy. A higher level signal in the hierarchy is obtained through the interleaving of bytes from the lower level signals. Each STS and electrical signal has a corresponding optical carrier level and OCN signal. The OCN signal are the same except for the use of scrambling in the optical signals. The SDS stands refer to the synchronous transfer modules. Estimate signal and begins at a bit rate of 155.52 Mbps. The SDS STM1 signal is equivalent to the SONET STS3 signal. Figure show the source multiplexing. Demultiplexing. The most important features to note is that all clocks in the network are locked to a common master clock. Multiplexing is only done by the byte interleaving. As a result, if each of an input stream has the same rate R, the multiplex stream has a rate NR. Because sorts are synchronized, the buffer at each input line will be very small as they have only to accommodate the effect of jitter. The degree, the degree relations of technology in the United States level to a situation in which the long distance carrier (MCI) as wind, AT&T, etc. were expanded to provide the interconnection between local telephone service providers to meet the urgent need. The synchronous optical network SONET standard was developed in North America. The CCIT later developed the corresponding set of a standard called the synchronous digital hierarchy. SONET and HDS form the basic of current high speed backbone network. The SONET standard shown in the table uses a 51.85 Mbps signal as a building block to represent digital transmission hierarchy into the multi-gigabit range. The STS1 signal content route traffic plus transport overhead difficulty can generate STC1 signal. A signal DS3 for STC1 can be a standard synchronous DS3 signal generated by M13 M23 multiplexer read signaling or some other books for M13 M23 realization. Similarly, a group of lower rate such as DS1, DS2, DCFT1 can be weighed into ST1 payload. A high rate wideband signal can be packed into a multiple number of concentrated ST1 signal. Example of high signature the figure of multiplexer of ITU at 139.264 Mbps sterling and a broadband ISDN signal at the 150 Mbps high level of concatenation to STCN signal are possible for higher rate tributaries. The STCN signal is created interleaving bytes for in STCN selected are vertically synchronized. Optical carrier are generated by synchronizing the STCN signal and then converting optical signal to optical signal. Note that the data rate format and training of the signal are identical. Thank you.